There are different types of crystalline solids. The first way we can break them down is to look at what are the individual pieces. Molecular solids are made up of individual molecules in a crystalline structure. Ionic solids have ions in their crystalline structure. Atomic solids have atoms put together. Now, these unit pieces have an effect on things like melting point, because molecules can only be held together by intermolecular forces, which are relatively weak. So ice is an example of a molecular solid, but it has a relatively low melting point because it's just held together by hydrogen bonds. Ionic solids contain positive and negative anions. They're held together by ionic bonds, which are very strong, and so ionic compounds have high melting points. If we think about the atomic solids, we can divide those by how those atoms are connected to each other. They could be non-bonding, so just a bunch of atoms. All that would hold them together is dispersion forces, and the only examples of this would be the noble gases. So at a very cold temperature, you can get xenon to be a solid. These are going to have very, very low melting points. Metallic atomic solids are the most common. These are held together by metallic bonds. And these are going to have varying melting points. We know that mercury is a liquid at room temperature, right? But things like iron, you have to get them really hot to melt. And then we have the network covalent solids, where, as the name suggests, the atoms are connected by covalent bonds. Covalent bonds are really strong, and so these are going to have high melting points. So this kind of summarizes the things I've already said. This is interesting, though. Some molecular solids can have different structures depending on how the solid was formed, and those are called polymorphs, or multiple shapes. A fun example of this is chocolate. There are 6 different polymorphs of chocolate, of cocoa butter. And they're going to have different melting points, and they're going to have different properties in terms of how smooth, how hard, whether they have bloom or not. So this piece of chocolate here, it almost looks like it's moldy or something, right? Have you ever found a really old candy bar in the corner of your cupboard or something, and you open it up and you look at it and you're like, ew? Well, this is this sixth polymorph, which is hard, it has some blooming. That's what those spots are. And it can't be formed from melted chocolate. It takes several months for solid chocolate to turn into this polymorph. So you've actually got a special thing here. It's not better, though. But it's not dangerous. You can go ahead and eat that. The texture might be a little off, but it's not harmful, and it'll still taste pretty good. These other polymorphs, most of them are going to melt in your hand. So, M&Ms melt in your mouth, not in your hand, right? So when chocolate melts in your hand, it gets really messy. And so the really high quality chocolate is going to be this 5th polymorph. It's going to be really firm. It'll have a nice snap to it. It'll be smooth and shiny. It'll melt in your mouth, but not in your hand, right? And so making chocolate is an art. There's skill involved in it. Ionic solids, we're going to talk about those in a separate section. Non-bonding atomic solids, again, those are the non-bonding solids. Sorry, I don't know where my brain went. We're talking about atomic solids in general here. Non-bonding atomic solids first. Okay, so those are the noble gases in their solid form. Metallic solids held together by metallic bonds. This is an illustration of the electron C model of metallic bonding, where metals lose electrons easily, and so they'll lose an electron or two. It'll go out, and these electrons are mobile, and they're like swimming around. They're like water around the atoms, and that holds them together. Varying bond strengths, so varying melting points. And the network covalent solids. These are things like diamonds and graphite and silicon dioxide. High melting points because the covalent bonds are strong. So this is a good kind of question to be able to answer. And it actually uses a lot of just common sense with a little bit of chemistry knowledge. What type of atomic solid is Au? Metallic. Why? Because it's a metal. That's all there is to it. That's it. So this is a metallic atomic solid. Any of the metals are going to form metallic atomic solids. Here's another one. Which solid would you expect to have the highest melting point? So looking at these, let's think about, well, what kind of solids are they? What kind of a solid is this one? Yeah, but is it a non-bonding atomic solid? Is it a molecular solid? Is it an ionic solid? It's ionic, because magnesium's a metal and oxygen is not. So this is ionic. What kind of a solid is I2? Well, this is not atomic. That's a molecule. So this is a molecular solid. And this would be the non-bonding atomic solid. So these different types of solids are held together by different things. What's held together by the strongest forces? The ionic one, right? Because this is actual positive and negative charges in close proximity. Ionic bonds are very strong. So this is going to have the highest melting point. This one would be held together by dispersion forces, and this would also be held together by dispersion forces. Any questions?